What's up, Team Trilogy? Jeff Hessler here, Maintenance Operation Manager. And today we're going to be discussing system charging with superheat and subcooling. Superheat and subcooling are the most reliable method to charge a system other than weighing in refrigerant. So before we get started, let's discuss the not-so methods. We all know the not-so methods. Those are the beer can cold method. That's when you take your hand and you hold it up to the line set and you feel it and you think to yourself, man, this is cold, ice cold, beer cold. This is the way to go. Everything's good to go. My system's working. That's not a method. There's no science there. So we don't want to get caught up doing that. We also don't want to do the I can tell it's working because it's sweating method. If it's 90 degrees outside and the line set is 60, listen, I'm 98 degrees and I'm sweating when it's 90 degrees. So that is also not a method. The hand over the condenser fan, it's blowing hot air, so it's pulling the heat method. Yeah, there's no science again. So again, we want to use the correct methods. That's superheat and subcooling. Now, again, other than weighing in the refrigerant, this is the best way to do it. So how do we determine if we use superheat or the subcooling method? We need to determine which metering device we have. So if we go inside the indoor coil, we wanted to see if we have a TX valve or a TE valve. That's a thermal expansion valve, and that is for subcooling. Now, if we have a fixed orifice, like the picture on the right here, that is for superheat. We're going to be looking for the superheat with the fixed orifice. And again, we're going to be doing subcooling with the TX valve. Another thing that we want to note, if we're pulling superheat, we're going to be pulling a saturation temperature on our low side gauge. For subcooling, we will need the saturation temperature for our high side gauge. Now, what is system superheat? System superheat from the inside of the evaporator to the inlet of the compressor. Superheat is the suction line temperature at the compressor minus the saturation evaporator. We're going to check that from a TP chart. The amount is determined by the indoor wet bulb and the indoor and outdoor dry bulb temperatures. It can be as low as 5 degrees, as high as 40 degrees, depending on the ambient condition. So the indoor temperature has to be normal, around 70 to 80 degrees, considered a load. And the outdoor temperature has to be about 70 degrees outside. So it needs to be above 70 for us to get a superheat reading. As the outdoor temperature increases, the superheat will go down. For an example, 100 degrees ambient temperature outside, it's about 5 degrees system superheat. 70 degrees, it's going to increase, so it's about 30 of superheat. That's 30 degrees of superheat. So to get our superheat temperature, we're going to get the wet bulb temperature. That's going to be for the coil, our closest to the air return. We're going to then next need the outdoor dry bulb. That's going to be the temperature next to the condenser out of the sun. You usually want to go below the condenser. Next, we're going to need the suction line temperature. That's the temperature taken on the suction line. Next, we're going to get the saturation temperature. We're going to hook our gauges up, and we're going to be looking at whatever refrigerant we're using on the inner ring. That's going to give us our saturation temperature. We'll take those two methods. We're going to then take our PT chart. This is on the outdoor condenser. We're going to then take those. We're going to get the reading of, say, if we have 64 degrees. The outside temperature, let's say, is 80 degrees. We follow our chart over to the right here. That would mean we have 15 degrees of superheat. So that's where we're going to check for how much superheat we're going to need. So if it's at 15 degrees, we read our chart, that's where we need to be. So we're taking our temperature here. We're going to take the suction line. That's the blue. So we'll take that suction line temperature. And you see it's about 130 degrees PSI. Inside the inner ring, that's the saturation temperature. So if you're using R22 refrigerant, 410 refrigerant, we'll want to go in that inner side ring right here. And we see we have 45 degrees. That's the suction line saturated temperature. We then take the line temperature here. You see we have 60 degrees. So it would be 60 degrees line temperature minus the 45 degree saturation temperature. That gives us our 15 degrees superheat. So there is our target superheat. Now, we can be within 5 degrees plus or minus that required amount. Subcooling. Now, subcooling method, again, it's used for the charging of the TXV systems. Subcooling is the addition cooling refrigerants below its condensing temperature. Subcooling is the difference between condensing temperature and liquid line temperature. To get that subcooling temperature that we're going to need, again, we're going to take a look at the outdoor condenser plate. And if we look right here, it says indoor TXV subcooling, 11 degrees Fahrenheit. So we need 11 degrees of subcooling. So we're going to look at our high side line here. We're going to take a look at that saturation temperature here. So as you see, it's 230 degrees PSIG. That's 110, the R22 side. That is going to be the saturation temperature. So 110. Then we're going to take the temperature of the line set itself, the high side line. And you see we have 100 degrees. So 110 condensing temperature minus 100 line temperature. That's going to be 10 degrees of subcooling. So our target is 10 degrees. So we need to be as close as we can to 10. If we need to add refrigerant, we again get close as we can to 10. The subcooling is too low, we will need to then add. If the subcooling is too high, 14, 15 plus, we have too much refrigerant, we need to then recover. Now, weighing in the refrigerant, again, is the most efficient way to charge a system. We'll want to locate the identification plate on the side of the unit. As you see here, we have 5.30 pounds. It'll also give you what refrigerant is inside the system. That's 410. Now, we want to put the refrigerant on top of the scale. Once the scale calibrates, you can hit 0 on the control panel. And then we open up our gauges and fill the unit to its factory charge. In this particular unit, it's 5.30 pounds, that's 410A. Now, once we get to that 530, if this is a second or third story unit where the line sets go through the attic, we're going to need to add more refrigerant than that factory charge. Again, this is just factory. This is a standard 15-foot line set. And if you have third or second floor, you will need to add Freon. For every 15 feet of line set, it's 0.6 ounces of refrigerant. So that 5.30 pounds not going to work for a second story, third story, or even a 4-story unit. More importantly, don't forget your HAPI-CO refrigerant law. It is very important for you to fill this out, put the date, the time, your name, the beginning rates, and if you can at that time, name the nature of the problem. If it's freighter valves were leaking or whatever the case may be, just make sure you fill that in. Thank you guys for attending today's system charging. If you have any questions, comments, please contact me. Most of you have my phone number. If you don't, you can just reach me at jhessler@livetrilogy.com. Thanks again for watching, guys. Have a great day.